The goal is to make reliable agents, and the goal is for the agents to improve. And there are three big ways to improve an agent.
Hi, everyone. My name is Taki Jafri, and I lead product for UiPath Enterprise Agents. I'm joined here today by Mircea Negovic, who leads our ML teams. Welcome, Mircea.
Hi, Taki. Very nice to be here with you.
Thank you. So, Mircea, why don't you walk us through what is the role of the UiPath AI teams and what do you folks do?
We started this team about 8 years ago, and the goal has been the same since. We want to use AI to make better products, make better automation. The projects have changed in those 8 years. We started more with computer vision, document understanding. Now we work more on agents, we do some work on computer use, but the goal has been the same: make better features for automation using AI.
Wonderful. And walk me through the team that you have. How many people do you have? Where they're based in the world?
We have about 35 or so people. We are mostly an applied science team. We use the latest research and apply it to our products. We have maybe 15% or so of the team does research. We want to advance science. We want to invent new things, publish papers, go to conferences, this kind of stuff. We have two professors who advise us in all the projects. We have David Barber from UCL. He's the head of the AI department in London. And we have Sarah Chasins. She's a professor at Berkeley. And both of them advise us in pretty much every project we do.
That's wonderful. I think let's get into some more detailed topics now. So when I think about ML, there's always this big debate about models. So we have these big models from the frontier labs and a lot of innovation happening in the open source world. So how do you think about the balance between using these closed source, closed weight models from the frontier labs versus the open source, open weight models?
We want to use both. We don't have a strong preference. We use whatever works best for a given feature. And of course, for different features, the answer is different. But in general, we start using the frontier models that allows us to ship new features in a short amount of time. And then we'll see how it works. We deploy. It's very important for us to do continuous learning, which means after we deploy a feature, like, for example, document extraction or agents, it's very important for us to keep improving those features. So then back to the question about models. In general, the frontier models, the closed weights model, hit a ceiling. In documents, for example, they don't really learn that much from mistakes. And here is where there is a role for the open source, smaller models, more specialized models. By using fine-tuning, in many cases, you can actually break the ceiling, and in the end, you can build a better or a more accurate product.
Got it. There's just so much to unpack here. The first thing, let's get into, when you talked about fine-tuning, are you fine-tuning each model for each customer separately, or are you just fine-tuning these models such that they get better for everybody?
It depends on the product and the feature. When we fine-tune models for computer vision or computer use or our OCR models, we fine-tune an open source model and we ship the same model to all customers. But there are other cases, for example, in document processing. In document processing, after we deploy the product, customers tell us via human in the loop what mistakes we made. And those basically labeled documents come back into our training set. But when we train now, we train per customer, actually per customer, per document type. Mm-hmm. So to come back to your question, it really depends. For document understanding, we fine-tune per customer. For agents, it will be the same thing because we are going to get signal from the user via human in the loop. And that signal will be used for a given agent. So for agents, we are going to fine-tune per customer, per agent.
Got it. But I think more specifically, these are adapters that you're training, right? Like these are LoRa adapters?
Yeah.
So why do you think LoRa is a better technique rather than fine-tuning the entire model, maybe for the audience?
I think LoRa's main advantage is how you run the service. It is a lot more efficient to run a service with LoRa adapters, which means the model is the same for all customers, but the adapter is different. So then you have a request, and the request comes with whatever information you need to predict on, plus the LoRa adapter for the customer. And that makes it very efficient. is not a very big advantage at the training time or the fine-tuning time. It takes a bit less memory, is maybe a bit faster, but that's not really the main goal of using the adapters. Are great for deploying, and then you can scale the service a lot easier. You can reuse the GPUs, and that's where most of the advantage of LoRa comes into play.
Got it. So it's like the same backbone with different adapters for each fine-tuned model.
Yeah, and it makes it a lot easier to reuse the GPUs, and you have to reuse the GPU to scale a service. You cannot have as many GPUs as customers, of course.
Exactly. And this actually leads nicely into the next point, because everything you said really applies to us hosting the service in a very efficient way to our customers. But we at UiPath also pride ourselves in being enterprise grade. And a lot of our customers want private deployments of these models, perhaps in their own virtual private cloud or even on-prem. So how do we think about GPU availability? Because it's kind of like a scarce resource right now.
On-prem, the customer has to provide the GPUs. But besides that, everything will just work. We'll use open source models as they are, and we'll use open source models fine-tuned for an agent or for a document. We have a framework at UiPath that allows us to deploy those models and to use the same framework to deploy on cloud and to deploy on-prem. Yeah, so for us, we want to keep supporting both cloud, of course, and on-premise customers, because some of the customers strongly prefer on-prem, especially for some of the automation scenarios.
Right, in some of these very highly regulated industries, they have a need to do that.
Yeah.
Okay, so I think let's maybe dive in a little bit deeper into fine-tuning more than just the LoRa adapters, because I think there's various techniques to actually do the fine-tuning, right? You can fine-tune the prompt, or you can actually fine-tune the weights. So how do you think about which particular technique to use?
Just taking a step back and take an example. How can we improve, for example, the agents? We talked about continuous learning. So the goal is to make reliable agents, and the goal is for the agents to improve. So now, how do they improve? And there are three big ways to improve an agent. One is you can learn a better prompt from the data. Not learning weights, but just learn a prompt. And there are many papers on this. We implemented one called Prodigy. It's just you learn a prompt from data. That's the easiest thing to do. Then you can use in-context learning. So you have some positive examples or negative examples in the data set, or you can give some signal from the user at runtime. And then in-context learning means you look at some examples and you augment the prompt with the example, classic in-context learning. And then there is the fine-tuning, which is a more advanced thing. I mean, for fine-tuning, you need some more data. You need at least hundreds of very clean and examples. For documents, we have a lot of those because the customers tell us what mistakes we make when they review documents based on some confidence scores that the model outputs. We've been almost exclusively until now trained with supervised fine-tuning. Basically, we train with prompt and completion, very standard. But now we believe there is a lot of opportunity for us to train with reinforcement learning. This is the case for both documents and for agents. To just give you an example, for documents, we believe that data is not clean. Whatever you do and whatever effort you put into it, there is always some reason, some issue with it. And now the models have a problem that actually they learn from dirty data. They learn to make mistakes, basically. With reinforcement learning, some of this can be improved. For example, if you write a good reward function while fine-tuning for documents, then you can make the model a bit less sensitive to labeling errors. If you have a reward function for GRPO, for example, that applies some of the rules, like for an invoice, the total of the items have to match the total amount, and then you have some business rules that the customer have, like some name of the vendor has to be in some database. So if you make a reward function based on those rules, then you make the model less sensitive to mistakes.
Wonderful. Okay, now let's get into some other research topics that you're interested in. So maybe you can walk us through for agents, unattended agents, for document processing, and for computer use. So what are some general research problems that you're working on?
Computer use is a very interesting problem for us as an automation company. You see a lot of activity in the space. Computer use means given a task, just execute the task. Use the mouse and keyboard and execute the task. And there is a lot of buzz in the industry, of course, and there's a very cool kind of thing.
Mm-hmm.
But is it ready for prime time? That's a very debatable thing. What we have done here, we have computer use now in production for very small tasks. And we can get those to be very reliable.
So maybe
For example,
give us an example. Yeah.
For example, there are things that are very hard to express by rules in a workflow. For example, you want to just put a date in a date picker control. It's very hard to click 5 times on that arrow for the month, the day. If you might need tens or more rules just for that. But if you have a prompt, the prompt is very simple. Just put the date in there. And then the computer use technology is now good enough to actually get it done. So it is simpler and it's actually more reliable because if the control slightly changes, most likely the automation will not break. But if it's done by rules, it will probably break. So this is something that computer use can do today, and we have this in production. Now, at the other extreme, there is very long tasks. For example, I've heard someone saying, do the taxes for me. I don't think that will happen very soon to do the whole tax. But some simpler things like, for example, book a flight ticket or go to my expense report system and attach receipts where I miss the receipts by searching in email. This kind of stuff with 20 to 30 to 40 steps, I think those will work. But I don't think they work right now. I don't think the models, I think the models have the right planning capacity, but I think they're too slow to be effective because everything they do, they have to take a lot of pictures. You click in a drop down, take another picture. So then they're painfully slow. But I think this is going to work at some point. So for us, we started with the very reliable, very small things. And now we are going to see how much more we can expand from there.
Increase the scope of it.
Yes. And just one more thing I want to say. The smaller tasks, the ones that are reliable, work in an unattended way. The longer the task is, the more it can fail, the more the human input is required. And those for now have to be attended. We'll have to see how much more complex the unattended tasks can be. And that's how we do. Coming back to your research, most of those computer use systems now have 2 phases. They have a planning phase and they have a grounding phase. And we do a lot of prototyping for both, improve the planning and the grounding. For the grounding, fine-tuning models usually is a good idea. For planning, not all the tasks require the same planning. So the smaller tasks have a much simpler planning. It's just usually one screen. As of do your taxes kind of thing requires a lot of planning. So I think we have to invest in multiple ways of planning depending on the task. And the grounding, which means just given the next action, you just do the click or the type. Those I think we have pretty much under control with our fine-tuned QN models.
Very cool. And just briefly, for these computer use models, you said a prompt is the input, and then the actions, the clicks, and the screen navigations are the output. But can you also prompt them with demonstrations?
Yes. And actually, the longer the task is, the more they are going to be prompted by demonstrations. Because really, I don't want to write a prompt that's very big. I don't know where it's going to break. I would rather demonstrate. But when I demonstrate, I don't demonstrate every single thing. Some of the things you have to infer from my actions and from the voice that goes into the recorder. For example, I'm going to say, do this for all the items in this list. I'm not going to do it for the other thing with demonstrations is that you can have 2 demonstrations because you might have 2 paths in the graph. So I very, very strongly believe in learning from the longer the task, the more I believe in learning from demonstration. The simpler task, you can just have a simple prompt.
Okay, so as we think about documents, I know documents come in all shapes and sizes. Some are scanned, some may be different layouts, short documents, long documents. So how do you think about representing these documents for the AI?
Yes, you're right. We've been working mostly with semi-structured and shorter documents, but now we expanded to longer documents and more unstructured. Reading documents has changed in the last few years with those new Gen AI models. The way to think about it for me now is that if you look at a PDF, reading a PDF is a vision problem. we've been using in the past with the models at the time. We've been doing OCR, and we've been using APIs that give you the text from a PDF. But those are imperfect, and even though you get the correct words, then it's very hard to make the right order of the correct reading order. So we have now options that we didn't have before with those GenAI models. The way we read documents now is we have a model that tells us where the text is or the table is. And then we can do decoding via the large language models, and that one works pretty well. But the problem is that in our scenarios, we need the bounding box for every word. And this is because our customers have to label the documents or they have to correct mistakes, and that's done at the word level. So for us, the sweet spot in document reading is to map the zones that we have now with the larger models with the more traditional OCR that give us the coordinates for every word. But in some cases, we can also do decoding, but then we lose the word coordinates. So there are really some trade-offs. But overall, we have a lot more options than we had 5 years ago, and the quality of reading the documents has increased. And that's actually super important. Otherwise, it's like we say, garbage in, garbage out. We now have a much better input for our DU models and in general for LLMs.
Wonderful. So as you think about all this innovation, both for documents as well as computer use and other things you do, how do you think about benchmarking? And do you have some benchmarks to share with us?
We spend most of our time evaluating different approaches. For documents, like I said, for the reading order, there are benchmarks about how well you understand the document. In particular, for computer use, we introduced a new benchmark because other benchmarks are not exactly a very good fit for automation and for enterprise applications. So very recently, we introduced our own benchmark. It's called UICube. And those are more business-oriented apps like Workday, applications and Concur and SAP and this kind of stuff. And it is actually a very interesting benchmark. I encourage everybody to give it a try. It is a hard problem. The best score we have is about 19%. So there is a lot of room for improvement. But we think the scores are going to increase quite fast. But as of right now, it's a very difficult benchmark. Actually, we have the benchmark is split into two. There is a simple benchmark. It's kind of a warming up kind of thing. And then there is the more difficult benchmark. The 19% is about the second one. So we have to see. I'm looking forward to see how fast this number goes up.
Wonderful. And I guess just in closing, what are some advances from your vantage point that you're seeing in the industry that you're the most excited about?
The world is changing. I'm very excited about coded agents, especially for our company. This might make a very big difference. We've done a lot of automation. We've used low code a lot. Now the question is coded agents, are coded agents going to be a competitor for low code? And I think it depends who you ask. You might get different answers. But I think for me, code is easier than low code. It's easier to read, easier to maintain, easier to debug. It requires a different persona. It requires an engineer, a software engineer versus an RPA developer. I'm not saying that a lot of the low code will become coded automation, but I think some of it will. And if you look at the companies and how APIs are designed, I think APIs have to be designed more for computers than for humans. And then once you do that, then those coding agents will have a very good way to do more complicated things. So I think I know we at UiPath try to make our SDK and APIs ready for this new era of coding. So that's, to me, something that we keep an eye on, and is a very exciting thing.
Wonderful. I agree. It's going to be amazing. It's a brave new world. Thank you very much, Mircea.
Thank you, Taki. Nice talking to you.
Appreciate it. Thank you.